Hello, everyone. Um, so, today we're going to talk about some policy enforcement and a bit of vulnerability management in terms of Kubernetes. So, hopefully, you're stoked as I am, and let's get started. All right, so our story gonna begin in a terminal, like always. And we're gonna create a cluster. So for this demo to work, the cluster needs to be in a specific, needs to use a specific distro. It's Debian. If you don't recall, like 4 or 5 months ago, maybe more, there was a supply chain attack in Debian, which pushed compromised version of a library, Leap ZMA, which sort of had this backdoor that a person or an entity or a enterprise, whoever, could use that key to gain access to other computers who which are infected by that sort of key. Now, if you want to know all about that drama, there is a great post somewhere in the internet about it. And here is like everything that you need to know from what happened. There's a QR code for it. Like what happened, what was the story, who did what, these sort of stuff. So that is one thing. But today, our focus is going to be on what happens if there are similar attacks, like new ones, 0 days, that we don't even know about. And sure, they're happening everywhere, but is there any sort of defense, or if there is some sort of mechanism that we can implement to sort of manage the casualties in terms of servers and stuff? So, with that, we're gonna create a cluster. This cluster is going to be in multipass. It's a local cluster of mine, just very basic. If you're looking to create the cluster, just come to this page and you could just follow along with me and like figure out what I'm doing as I'm doing it, why I'm doing it, and these sort of stuff. But anyway, let's get back to the cluster creation. So basically, these two commands, one creates a control plane and the other one creates a node for that cluster. The control plane uses K3s, not relevant to the story, but we needed a Kubernetes because we are trying to figure out how to mitigate these sort of attacks in Kubernetes. The only significant thing here is going to be Debian, as I said, because there are a couple of packages that we can still pull from the archives of Debian, which are infected with that specific problem. So nothing spectacular about this Kubernetes cluster other than it uses Calico, which is super nice and easy for me. And to figure out if it's actually working, we just need to check the Tiger status. So this command, if you have installed Calico via an operator, should show you what is the status of your Calico. Just a reminder, if you got any sort of questions, let me know in the chat. Hopefully I know the answer. If I don't, I'll fetch one of our engineers who can help you with your problem and me with the answer. All right, so now that we have a cluster with 2 nodes and it is ready, so that means the CNI binaries and configurations are in place, and most of the pods are running, so I'm assuming everything is working. Now let's check some of the stuff. Now, if you recall, I talked about the library that was infected. Now, this particular attack, sort of happened via SSH. Now, SSH wasn't directly affected by it, but as you may know, SSH provides a lot of plugins or things that you can call while the authentication or handshake or the stuff that are happening to relay some of the responsibilities to other sort of plugins. For instance, you can add single sign-on capability to SSH, or you could add other sort of capabilities. For instance, you could add what's it called? New encryptions or your private sort of encryptions into SSH. Now, this particular attack was sort of based on this notion that SSH, let me just, all right, so this was banking on the idea that SSH binary is going to relay some of the authentication, SSH authentication to libLZMA in order to unzip or unpack the authentication handshake. Again, if you want to know what exactly happens via this attack, that web page that I showed you has all the things in it. So that is the best place to get to know what happened, how this attack was forged, and how it actually worked. Now, what we're gonna do is we're gonna create another sort of terminal, and in our second terminal, we're gonna actually, I can do it a bit easier, which is we're gonna use the IP address of my control node to actually run the attack. So as you can see, the handshake fails, which means at the moment, this particular distro is not vulnerable. Now, it is important to know the best way to mitigate any attacks is to download the patches and fixes that the community or the developers publish. Now, before that, you could use these methods that I'm showing you to actually sort of add a layer, make it more difficult for the bad actors to gain access to these sort of attacks. All right, so let's get back to the cluster. Now there is a file here which asks for your permission, and if you give it, it will make your setup vulnerable to that specific CVE. Now, if we come back to the attack pod or the attack container and do an attack, you see the prompt changes, which shows we can actually do the attack and get access to the server. Now, the funny thing is, at the moment, my user is Ubuntu, which is not root, but the attack was actually able to take advantage of that key and authenticate itself as a root user. So I can't even get rid of that file because, again, I'm not a root user. So what we can do if we have a server that might be vulnerable to a zero-day remote attack. Well, first of all, the best preventive sort of measure is to implement zero trust. Now, zero trust is just a phrase for a lot of hardening around your environment, putting like armed guards in front doors and stuff. But in this context, where we could start is by implementing policies. Now, Calico is a network and security solution for Kubernetes and virtual machines, and it comes with a policy engine that allows you to write policies for Kubernetes. Now, all you need to do from here or in your environment is to start writing policies. Now, that is sort of vague, so let's get into it. So, first of all, the attack happens on the SSH servers. Now, if we check, SSH is actually running on port 22 and it's on the local socket. It's on the host socket. There are no pods in my environment that are hosting the service. So first of all, here is a problem that we have with Kubernetes network policies, because Kubernetes network policies do not apply to the host. They're usually they're usually effective if you're trying to secure a pod or a service. So first thing first, we need to enable host endpoints. So Calico extends the capabilities of Kubernetes and, excuse me, it actually implements a resource called host endpoint. Now, host endpoint is sort of like a label. It's a resource that provides you a label, and that label can be used in Calico policies and Calico global network policies to refer to that resource. Now, these resources can latch to things like network cards, which allows you to write policies for your host. Now, to enable host endpoints, there are two ways. You can either write a host endpoint resource manually, or you could enable auto creation. So auto creation actually uses Calico Kubernetes watcher to figure out how many interfaces you have and just creates these resources according to it. Now, these resources are created in the hep subcommand. So if we look at these resources, so each one of them is with a kind host endpoint, and it is usually latched to interfaces. Now here, interface name is an asterisk. If you're familiar with regex, that means everything. So you can actually write pattern here, for instance, ENS star or ENS dot, depending on what you're trying to achieve, to make sure that your host endpoint is actually attaching to the interfaces that you're expecting it to. You can also provide IP addresses to say this host endpoint sort of needs this IP address to be shown. Any other sort of traffic should not be allowed. You can also you should also add a node, because again, host endpoints use node selectors to know which interface on what node you're trying to attach this policy to, this resource to. Now, when you have done everything, there is something called profiles. Profiles are some sort of allow or deny that happens on a bigger scale. For instance, you can have a profile that allows everything or denies everything, which would change the behavior of your Kubernetes from everything is always permitted to everything always going to be denied. For more context, Kubernetes network policies or Kubernetes policies by default permits everything. Unless you write a policy, then that behavior becomes to deny everything. All right, so next, we're gonna create a policy that can actually use our host endpoint. Now for that, what we need to do is look at the policies that are provided inside the lab. So there's a lot of policies here. If you want to know how they're working, there's actually a page here that you can, here's a QR code for it. So it actually goes over how these things works, what are selectors, what are rules, the precedence with the order number, what happens when you create a policy. Then it talks about lockouts, how you can actually, because remember, when you're creating a policy, you're actually changing the default behavior to deny everything. So if you deny everything and you disable safe ports, which is just a measure in Calico to make sure that you don't lock out yourself. You don't lock yourself out of your cluster. So if you do everything and some of your policies are not correct, there is a chance that you can lock yourself out, and then you would need to access your environment via serial or a keyboard and a mouse, which could be a bit difficult in some scenarios. Anyway, so this page is gonna talk about all the things that happens in terms of policies that you write, the actual things that happen in a visual way, and it should give you all the information about these policies. So with that in mind, the one that I'm interested in is this one. So when you implement host endpoints, you're actually like, you can write policies that can limit pods or any sort of local traffic. So in order for your local binaries, local host binaries, or pods that are using host network sort of communication to be able to flow, you need to say that a host endpoint resource with that label needs to communicate with my local domain. Now, where this comes from, I'm glad you asked. So this one is coming from here, and I believe it was, I guess we have to check again. Yeah, Kubernetes.io.os, Kubernetes.io/os. So this particular selector, which is a Calico way to say if there's a resource that has this key, then this policy applies to it. Now, since this policy is a global network policy, it means cluster-wide. So I don't need to go write it in every namespace. It's just if there is a flow and this is happening, make sure to do whatever it is. So here we're allowing it. Now action could be deny or could be log. Again, we're getting to that. I believe there is a log somewhere here. Yep, there's a log here as well. So we're gonna get to that as well. Now, one more thing, I talked about safe ports. So there is this fail-safe mechanism, which by default it's on, and it actually works. It actually covers bunch of ports. I believe these ports are safe. Yeah, I believe these ports are documented here. As you can see, SSH, DNS, DHCP, these are allowed in the context of the host. So since we are trying to secure host SSH access, what we need to do is we need to disable failsafes. Now, disabling failsafe happens by patching Felix configuration and putting an empty array for fail-safes. Now, Felix is the brain of Calico, and it's the component that actually manages everything. So when we do this, fail-safe is no more working in our cluster. And if we write policies, then those should be the factors for what is going to happen for our cluster. Now, as I believe I've showed you, but there's a policy here called log. Now, when you write policies, there's a precedence, and policies with the order number that are closer to 1 or smaller order numbers will happen first, and policies with the higher number happen later. Now, this allows us to sort of write policies that happen in particular order, allowing us to sort of curate what sort of behavior we like to see. Now, here, if I check again, I'm not root. Oh, it's journal nonsense. So journal cattle. I believe it's F, and we should look for a packet. All right. So a log policy a log policy would send traffic to your syslog. Now, why is that important? So in cases that none of the policies that we wrote, so from here, these will happen first because they have a smaller order number. So if a traffic comes in and does not match to any of these policies that are crucial for our cluster to work, then at the end, it will match this policy, which is like log everything. And then it would emit a log into the syslog, or for example, in this case, journal. So when that happens, we could go check that specific flow to see what is going on. It could be used for security purposes and other sort of things. Anyway, I'm getting ahead of myself. So now what we need to do is check the temp folder. There's no XZ proof. And now go and do the attack again. So this time, again, I didn't change anything other than implementing a couple of security policies. Because I implemented these policies, Calico is actually enforcing rules that are not letting this attack happen. So it's actually telling me a source is trying to access port 22 with protocol TCP. And because our policies does not allow this, it's preventing this flow from happening. Now, this is for this tag specifically, but as you can see, if there is another zero attack that needs SSH or any other sort of services that are not controlled by our engineers, we could basically secure it without even knowing about that attack. So this is actually mitigating any sort of future attack that can happen on this service or any other service that we are not explicitly letting it to be accessed. Now, one more thing here is, so other than this, we also have a scanner that is part of Calico Club. Let me just use the other one, which has the QR code scanner. All right, so I talked about securing the cluster, but again, securing cluster is one thing, but how we can figure out where are the vulnerabilities, or if we are using some sort of library or a service that is compromised. So in order to check that, what we could do is we could use the Calico Cloud scanner. So with Calico Cloud, there is an image scanner that can be put into your cluster or into your pipeline, depending on what is the measure that you want to use. Now, this scanner is free. You can download it. It is not open source, but it is free, and it runs this scanner. It runs this application that allows you to scan images and figure out if there are any vulnerability associated with that particular library or container. Now, let me just go ahead and download the image scanner. So in order to use the scanner, all you need to do is you need to download the scanner, obviously, from our website. Let me just expand this a bit. And actually make the scanner executable. So after you downloaded the scanner, you can say, well, I want to scan a container. Now, what this does is I do have a vulnerable library, container, which I used. So what it does is it uses your container runtime environment. It actually uses Docker SDK to communicate with the container runtime environment, and it checks the checks the container image layer without extracting that image. So if we look for RCE, I believe that was something else. So CVE 2024 or something. Yeah, if we look here, we should see the, actually I can do better. I can do less, which is sort of more, but it's called less. I never got that. But anyway, so this would go ahead and check what are the vulnerabilities in your container image, and I think it would be better if I, yeah. And just tell you like, all right, you got these vulnerabilities, and the scoring again comes from CVE databases, and tells you like, all right, I know you're gonna do something, but if you really want to do it, here is the lay of the land. Make sure you know what you are doing. And I believe that's it for this session. Let me check. Yep. Yeah. Shared this. Oh, here is the actual blog post. If you want to know what was the motivation behind creating this, where to download the scanner, how you can use the scanner, policies, fail-safe, and these sort of stuff. A guy called Reza wrote it, so it should be good. And if you like to know more about like previous attacks, which again we talked about, and if you would have done that, you would have been safe for the XZ attack, which happened later. Anyway, so again, same sort of scenario. You just implement policies and it prevents people from accessing your stuff that are not supposed to. And that's about it. Thank you for viewing, and hope to catch you in the next one.